So let's talk about pure destruction. And so we're talking about decomposition reactions here. Um, the learning goals for this, we wanted to identify a chemical reaction as a decomposition reaction, calculate the molar mass in decomposition reactions, and describe applications of decomposition reactions. What we already know, chemical reactions change the reactants, resulting in different products, and synthesis reactions create larger molecules. What we learned in the lab, large molecules can fall apart into substituent molecules. Now, mole, revisiting this again, it's a very important topic in chemistry. The mole is a unit of expressing large numbers. Just like a dozen, a mole means 6.02 times 10 to the 23rd. So we can have a mole of anything. We can have a mole of atoms, a mole of molecules, or a mole of ions. So, molar mass, we know that molar mass equals 1 mole. It's that many atoms, 6.02 times 10 to the 23rd. It's the mass of those atoms. Now, molar mass is the mass of 1 mole of the substance. The molar mass can be determined by the periodic table. That's where we find our molar masses. For instance, sodium has a molar mass of 23, chlorine has a molar mass of 35.45. That's what it says on the periodic table. So, molar masses, we can combine those molar masses for compounds, just like we have 23 for sodium, we have 35.45 for chlorine. Sodium chloride has a mass of 58.5. So, let's look at our first example. It says, what is the molar mass of carbon? Well, it tells us on the periodic table. It's 12.01 grams per mole. Next question. It says how many basketballs are in 1 mole of basketballs? So we're talking about 1 mole. We're talking about a quantity. So therefore it is going to be our quantity of 6.02 times 10 to the 23rd basketballs. And lastly, our mastery level question. It says how many atoms are in 14 grams of nitrogen? Now, nitrogen has a molar mass right around 14. So essentially by saying 14 grams of nitrogen, we're talking about 1 mole of nitrogen. So 14 grams is 1 mole, which 1 mole is 6.02 times 10 to the 23rd atoms. Now, jumping into a decomposition reaction. It's a class of chemical reaction, and reactants fall apart into 2 smaller products. Main thing here is that you're starting with one thing going to multiple things. So your reactants will be 1, your products will be more than 1. Now the energy in a decomposition reaction, chemical bonds are broken into decomposition reactions, and energy is released as broken bonds raise the temperature of surroundings. So if we're losing bonds, that means we're losing energy to the environment. A decomposition is an exothermic, so we're releasing energy. Now, some applications of a decomposition reaction. The decomposition of potassium permanganate can be used to produce oxygen with very, very little waste. And so we can produce pure oxygen by decomposing potassium permanganate. Let's look at a developing level question. It says compare and contrast the synthesis and decomposition. Well, decomposition, what we're doing is we're breaking things apart, taking one thing and breaking it apart. That's how it's different than a synthesis. A synthesis is taking multiple things and bringing them together. Now, where they have common ground is that if we decompose water, so we take H2O and we break it up into hydrogen and oxygen, the energy that it took to break it up is the same energy that it takes to put it back together, because that's the law of conservation of energy. Next example, it says which of the reactants below is a decomposition reaction? So pretty easy. We just look for the one that has one reactant. And the only one that has one reactant is that right there. And that's a decomposition reaction on top. And our mastery level question, it says the relationship between ozone and oxygen is shown in the chemical equation below. And it says, would you classify this as a synthesis or a decomposition? So we would classify this, since we have that arrow right there, it's going backwards and forwards. It's an equilibrium. And so what we would say is that we would say that ozone is synthesized and then ozone is decomposed and it breaks apart because it's an equilibrium going back and forth.